चलो हेलो एवरीवन, गुड आफ्टरनून एंड वेलकम टू डिजिटल नालंदा। सबको जय भीम। और आज हम जुड़े हैं एक विशेष सत्र के लिए। डिजिटल नालंदा ब्रिंग्स टू यू स्कूल ऑफ इंफॉर्मेशन एंड डेटा साइंस, जिसका आज इनॉग्रल सेशन है। एंड since beginning of our like this venture, we were asked about like when we'll begin. Do we have any such faculty of data sciences? And because it's a buzz thing now, and also students, I mean, they are required these kind of skills, and they are like very much in. I mean, they are very much in need, and people ask, and there are many places where we can get such education, but nobody knows from where it is to be taken, or from which faculty to take guidance from. So we have with us two of our distinguished faculties. Let me give a brief introduction. We have with us Sir Subodh Patil with us, and who is joining us from the Netherlands with us, and also he is faculty in Institute Lawrence for Theoretical Physics in University of Leiden in Netherlands. And welcome, Subodh sir.
Thank you very much.
Also, we have with us Dr. Mohammad Ramis with us, who is faculty at the Tata Institute of Fundamental Research in Bombay. He is in the Department of High Energy Physics, if I'm not wrong, sir. And also he has, sir, and also he is one of the school coordinators, as Subodh Patil sir, of our Digital Nalanda's School of Information and Data Sciences. So welcome, Ramesh sir. And
thank you for that. Welcome.
Yeah, I hand over to Subodh sir for the inaugural talk.
Thank you very much, Subodh bhai. I just want to say it's a great pleasure for Ramiz and myself to be joining you today. Jai Bhim. We are very excited to inaugurate what we hope will be a self-contained program. We're going to begin with some very basic material, just to sort of set the stage, just so students can see what the path is ahead. And as the months and weeks go on, our intention is to add self-contained introductions to all of the material that one needs to navigate the basics of data science and one of its more interesting applications, which is to machine learning. So there's a lot of material to cover, and so we have a long way to go. But in order to see, in order to get to a destination, first you have to sort of maybe see the summits and the peaks of the mountains ahead to give you some motivation and some excitement. Although this introductory lecture will be in English, and subsequent live lectures will also be primarily in English, we will also endeavor to record pre-recorded lectures in Marathi and Hindi, and perhaps also Malayalam if Ramiz can manage that. And when it comes to communicating with us, please just talk to us in whatever language you feel the most comfortable in. As we were instructed, the slides will be in English, and this is because as you pursue education in this field, if you decide to pursue it, it is something that you should be getting used to. And so our goal is to be your guides, foremost, and hopefully even get you excited in this field. So I'm going to share my screen and begin with just the overview lecture. So we're going to begin with excuse me. So this is the overview. So the way we've structured this introductory set of lectures is today we're going to basically have what we had initially planned as lectures 1 and 2, but it's really just an introduction to what data science is, because you may have heard of it as a buzzword. It's around. Perhaps the most widely more famous buzz expression you may have heard is data is the new oil. Okay, so it's become such a precious commodity and a resource that people think that in the next decades it's going to be as valuable as one of the most precious natural resources we have, and we'll see why. But in order to sort of unpack, the meaning behind these buzzwords, we have to, we have to really get into it. And this is what we hope to provide in this introductory lectures, to first just understand what it is. It's actually a lot of things. It's a lot of things. It's a multidisciplinary subject. And so over the course of, let's say, going from knowing nothing to being somebody who wants to pursue a career in data science, you will have learned not only a lot of statistics, but also a lot of computer coding, and primarily, and this is where I know Ramiz and I are very excited. This is also where you get to learn about critical thinking as a scientist, and this is to us a very important skill. And so the first lecture will present just an overview of what data science is as a subject. We will also sketch the path of what you need to become a data scientist. And before we get into this, I just want to share with you, some personal anecdotes about what it means to pursue anything in life, academics or anything. Everything begins with some small steps, and very often, with enough determination and application, things that seem impossible. If you look at a piece of paper, oh, I have to learn all of this. How could I possibly do this? What seems impossible at the beginning is in fact not only very possible, it's something that you will do very, very well if you apply your mind to it and if you work hard at things. Nothing is beyond your reach. And this is something that we will endeavor to, this is how we will endeavor to present the material. Because very often, and this is a problem everywhere in the world, not just in India, the way science and mathematics is sometimes taught in schools makes it much more, not challenging, shall we say, but it makes it seem less engaging as a subject. It makes it seem like a collection of things you have to memorize or things you just have to shut up and do because somebody told you to do. That's not how we're going to teach you. Our goal is to teach you in such a way that you will internalize the material yourselves. Our goal is to teach you in such a way that you yourself, after every lecture, can run away and go home and teach your friend the material. It's really aiming to help you internalize the material. And the consequence of this is when you feel this level of mastery over something, no matter how small it is, it empowers you. It makes you feel like you've understood the world in a much better way. And this is something that we want for you. It's for us, it has been a part of the joy of our learning, and it's something that we want to share with you. Of course, data science is also a career path, and a very lucrative one. And in general, not just data science, but any career in the science, technology, engineering fields are a huge means for upward mobility, meaning that it's a huge way for you to better your lives and those of those around you. I think almost everybody I know who is a scientist, in the West where I work, who comes from places, from countries that are not Western, they've all come from very, very far from where they began, including myself. And this could be the beginning of that path for you. This is what we want for you. And one of the things that we've designed our course in such a way that it should become clear while you're learning the material that there are some actual applications of the material immediately to things that are very, very relevant to your lives as a citizen and as a person. And the slogan which we want you to go away with is that an informed citizen is an empowered citizen, and that's what we want everybody to feel here, is to feel empowered and to be empowered and to make a change. And one of the things that you will benefit from with with the knowledge that we hope to cover is the means to be skeptical, the means to not just be a passive consumer of information, of things that you're told in the news or that you read, is to actually be able to apply some of the skills that we're about to teach you to real life examples and make informed decisions for yourself. Okay, so the application lectures that will begin, this will begin next week. The first one will cover something that's been very much on all of our minds, which is the current COVID pandemic. And it is a very useful way for us using only 10th standard mathematics. So when we say that this course only assumes 10th standard mathematics, we really mean that. It really only assumes something that you've all learned by standard 10. However, it will assemble it and build off of it in ways that you will find very, very surprising. And so there will be exercises that you will be asked to do to really master the material, and it will build up very fast. Okay, so you will you will be expected to really make an effort to master the material again and again and again, because practice makes perfect. And then from this foundation, you will be very, very surprised by the end where you'll end up, which is at the level of someone who we would trust to go away and analyze data for us. Okay, so that's where we're headed. And so there are various concepts, there are various things that come with big, they have big words attached to them, like sampling error and statistical inference and Bayes theorem. These are all things that in the first lecture, these are, if you like, some of the foundations of data science and statistics, and we will cover them immediately in the first lecture, assuming nothing more than 10th standard mathematics. I would stress, though, that our goal is later to provide a self-contained introduction to the mathematical background you would need to master more advanced material. That's also something we aim to provide eventually. So returning to the example of the coronavirus pandemic, we will also cover what you might think is a simple case of how to interpret a positive test result. It's actually very surprising. If you test positive for COVID, it's not certain that you have COVID. And in fact, depending on the accuracy of the test, let's say the test only gives wrong results 5% of the time. But it actually turns out that it's not quite true that if you get a positive test, there's only a 5% chance you don't have COVID. In fact, it could be much, much less. And so we will understand why in a way that I think should be very understandable with just the basic material. And we will understand the mathematics of random testing and prevalence. And so things that you will have read about in the news, numbers that you will have seen ministers talk about on the news, is something that you, hopefully, by the end of the first lecture, will be able to look back and understand why, and actually maybe even think, that person doesn't really understand what they're talking about. Because unfortunately, the government itself, everywhere in the world, has not necessarily been fully informed as this pandemic goes on. The statistics is the science of uncertainty, and we are surrounded by uncertainty. And so it partly becomes an art of thinking about numbers as well. So that's where we will start to begin with the first lecture. I'm going to hand over to Ramiz now.
Yeah, so we will continue on this theme of in this introductory course using real life examples to illustrate salient points of what makes up data science. So another thing that you must be very familiar with is that whenever there is an election about to happen or immediately after the votes have been cast, a large array of people come up on TV and they will make predictions about who wins. Some of them will be willing to bet money on it. And they follow a sequence of processes to arrive at these conclusions. This involves, of course, they cannot conduct the election themselves, because if they were able to ask every citizen, then they would have, in a process as reliable as an election, then they would be conducting the election twice. So what they normally do are different methods, such as there is exit polling, which is taking a small sample of people right after they have cast their vote and asking them. There is opinion polling, people call people up, and all of these methods have their advantages and disadvantages, in the sense that for example, if you decide to sample a very small group of people in a very diverse country like India, maybe you will not get the numbers right. And this is why quite often when you listen to election predictions right after an election, quite a few media houses which have very well trained statisticians among their teams turn out to be wrong. And so this example will be taught to you by Subodh in lecture 4 and he will use this example to introduce each of the concepts that are mentioned here. How to identify if your sample of a small sample of, let's say, 10 people whom you are asking questions to understand the opinions of a much larger people, 1,000. If that sample is representative, if you're going to make mistakes that way, how do you quantify how likely you are right, how likely you are to be right or wrong? Such ideas will be introduced in this lecture. And also, what are the aspects of an election that will determine what fraction of the total number of people turn up for polling? For example, we have seen that in India, this is a very large number. It is often as high as 80%. And this is often taken to mean that we have a very high level of faith in our democracy and a high level of engagement. And in some advanced countries like the United States, these numbers are often, the voter turnout is often as small as 40%. And that might mean that people there are less engaged with their electoral process. And depending upon, there are also outcomes of like who will win the election that really depend upon the turnout. And that tells you a story of different aspects of the electorate and how they are likely to vote. And such aspects of election polling will be covered in lecture 4 by Subodh. And if we could move to the next slide, I guess. Yeah, and then in lecture 5, I thought I would introduce one other major feature where in almost all of you must have come across this. For example, if you are using a credit card or a debit card or even UPI to make payments, you will sometimes notice that the payment is intentionally rejected by the bank, even though you are following the same process you have done the previous times. And this is because the bank is trying to prevent what it believes could be a fraudulent transaction. But the bank cannot really do that for, let's say, it has to have a set of criteria to identify how this is done. It might be based on geographical location. Maybe you make all of your payments around Bombay, or you make some of your payments, or there are a series of cities you travel through where you make your payments. And these payment, when you send the data for a payment, it is time-stamped with GPS, etc. And so they do what is called a clustering analysis, and any outlier requires then often maybe it is rejected, or maybe the bank will call you to immediately verify that you have made such a transaction. Sometimes they will go for something called two-factor authentication. That is, even after you enter password, you will have to enter an OTP that you get in your phone. And you realize that these are all conditional decisions made on your past behavior. So that is usually called usual behavior analysis. How do you, for let's say 90% of your transactions behave? How can a system learn that from your behavior and then use that information to identify what transaction is most likely to be fraudulent, so that your money can be protected? Another thing is identity management and tolerances. For example, many things today are designed based on detecting on an image of your face. For example, facial recognition. If some of you are using iPhones, I don't know how common that is. It is too expensive for me. But if you're using iPhone, sometimes you can unlock it using the camera, and it manages to do so even if you have a beard, if you don't have a beard, if you're partially shaved, if you've just woken up. And how does it recognize that? But if you show it a face that looks very similar to yours, it might still be able to tell, no, this is not the same person, and deny you access. So such systems are trained on a background of mathematics, of applying mathematics to classify photographs and understand how to recognize outliers. And we will go step by step through some examples that are actually implemented. A friend of mine who's a consultant for Bain and who worked for the National Payment Corporation of India, the people who manage UPI, he has given me a series of cases of things they have actually implemented. So we'll be going through actual implementations in this case. And then one of the things I wanted to go for is this fun law called Benford's law. For example, if you take a large collection of real life numbers, such as the electricity bills of a large number of people, the water consumption of a large number of people, what you will find is that the probability that the first digit of the number is 1 is roughly about 30%. And this might not seem intuitive to you. In fact, to me, it is off the top counterintuitive, because there are 9 numbers, 1 to 9, and if it is a 0, you don't write it, right? So, and I would believe each of them are equally probable. So if they're uniformly distributed, then I would assume that you have each numbers having 11%. But this turns out not to be true, and we will actually look at some of the reasons for this. And in fact, people have used this to identify fraudulent data. For example, if the government is engaging somebody to gather data on a specific purpose, they can either actually go out, spend money, and gather the data to help the government make the decision. Or if they are not very ethical, they can try and just make up those numbers. And people who are not aware of these real features of real data often make these silly mistakes when they make numbers up. And that is one of the ways by which people detect fraudulent data. So these are some use cases we will go through in your lecture 5, which I will be covering. And then if you can move on to the next slide. So yes, the basic overview of this course has been laid out now. What the next few lectures will cover, what you will learn as your course objectives is a basic understanding of the core concepts. For example, in the next slides, Subodh will tell you what is data, what is a science, what exactly is the layout of data science. Then I will give you a clear path towards becoming what are the specific skills you need to have, what are the things you need to know and understand. And of course, everybody is learning on their job, so the path towards becoming a data scientist is a path in itself. And then you will learn to appreciate that data is vast. You consult any data set, you will have very large numbers, and obviously in that form it is not useful. There is always often a small subset that you would call your signal, the thing you are looking for, or maybe the signal is a pattern within the data, and you will learn to recognize this. And you will learn that data analysis can often be wrong, and this is why, as we mentioned in the previous examples, election polling can quite often give you the wrong outcome. People are often wrong. So you will learn that it requires care and interpretation. You will learn how exactly you extract meaningful information from data, and by seeing a few real world applications, the ones we mentioned in the previous slide. But the single most important aspect that we want to emphasize is that while we are giving these lectures, it is important that all of us have fun doing so. And of course, so if anything goes over your head, please feel free to immediately ask us to clarify, to explain things better, etc. Because it is important that all of us have fun doing this. And I do not think a monologue is fun. A conversation is fun. So yes, thank you. I think Subodh will now move on to the the core aspects of the material.
Yeah, so maybe if this is a point where anybody has any questions about the outline of the course or the logistics of the course, please feel free to unmute the microphone and ask. Otherwise, I'll move on to the next next lecture. And I should stress that during these lectures as well, I do appreciate being interrupted. One should think of this as, of course, the digital format is difficult. We're not in front of each other, but if we were in the same room, I would make us all sit around in a circle on the floor, and I would like it to be this way so that we could all feel like this is a conversation. And I don't want this the set of lectures to come off necessarily as a teacher or a student standard format, rather that I'm somehow just a guide for you through the material, that we are your guides. We'd like to stress that this guiding will extends beyond the formal lectures. So we've arranged for question and answer sessions every Friday, where we can have more of a conversation about things. Of course, as things progress, as we develop more course material, as we may get more people joining in, the format may change as well. So as of now, I would just stress that if you have any questions, please do not hesitate to stop and ask. And again, to emphasize, the lectures are formally in English. There will be recorded lectures also provided in Marathi, in Hindi, and in Malayalam, possibly. And please just communicate with us in whatever language you feel most comfortable. So we're going to begin now with sort of a, yes,
so,
please.
Sir, there's
yes.
one like from the YouTube.
Yes.
Dhongre is asking that will you be covering Python? I mean, he's asking about whatever means like.
Yes.
Yeah.
Yes. Thank you for the question. So that is our goal. That is our ultimate goal. So to begin with, we're providing a set of 5 lectures that we've titled them an invitation to data science. And for that, we are assuming no knowledge other than 10th standard mathematics. Now, the format of the course that we aim to provide is a multi-stream set of courses. So every subject we have that we will present several streams. One of them will be very, very basic, assuming a bare minimum of mathematics. One of them will assume the same, but with some knowledge of coding. Now, for a lot of people, they may not have any coding background. So it could be that we also design some modules to learn to the basics of Python, which if you're scared of that word, if you've seen it and you're comfortable with it, then fantastic. But if you haven't, it's not so difficult to pick up. It just takes practice. It's like another language. That's all you have to think about. It's just a different language. And on top of that, then we anticipate adding a third very advanced stream, if you like, where we also introduce the more advanced mathematics that we need as we go along. So Ramiz and I have a lot of experience in teaching at all of these levels, so we feel very comfortable doing this. And the goal is perhaps if you're a complete beginner, you can work your way through each stream and then eventually get to the highest level. If you have some coding background, then you can immediately switch into the second stream. So that material will definitely be coming in the coming months, weeks or months. So I see that there may be more questions. Are there more questions?
There was regarding that do we need a basic coding experience before joining? So you have answered it now only. So we can begin with the next.
Yeah. So these introductory lectures assume nothing other than 10th standard mathematics. But as you will see, that's not saying that these lectures are if you like, elementary material. You will see how advanced it can get very, very quickly. And I think
one more question.
Yes, please. Please ask your question. If you have a question, please just unmute yourself and ask, please.
There is one more question from YouTube.
Okay.
The question is asked by Ashmita Kamble. After completing this course, will you help us in making portfolio? Like on what project I worked? This is the question.
So we haven't thought that far ahead, to be honest. But you know, I think whatever needs the students have, we are more than happy to try and accommodate the best we can. So it's, you know, my first reaction to your question is yes, of course. You have to also appreciate, though, however, that Ramiz and I, myself, or if you like, our day jobs, our professions are quite removed from data scientists. You know, we're both physicists, we're both astrophysicists, but we deal with data science quite a lot. And so when it comes to finding, you know, professional help or, you know, professional counseling, we will either provide it ourselves or do our best to find somebody in our network to help you. So I think what I would like to stress is, you know, there's no request that a student has that is off above board. Please, you know, whatever you may need from us, just ask and we'll do our best to accommodate. So indeed, if it means, you know, helping put together a portfolio or something like this, then, you know, just approach us and we'll do our best.
Thank you, Dr. Subodh. There is another question on YouTube. It's about whether a student even without college degree can join. For example, like students who are in 11th or 12th who have a grip over coding. Can they join?
Absolutely, absolutely, of course. I mean, our intention is, you know, whatever your level. Okay, so even if you are already in university at college or in college and you know you feel like you've understood, you know, some of the basic material to begin with, then I apologize if this seems a little boring to you. But I promise you that there will be new things that you haven't seen before, even in the basic material. And if you're starting from zero, that is really our intention, is to design something that is self-contained and can take you from having no knowledge of data science, no knowledge of coding, no knowledge of advanced mathematics, to being somebody who can consider themselves a practicing data scientist. So that is indeed our intention. It's going to take a little bit more of work, and so this, as you will see over the coming weeks, more and more things will be added onto the digital Nalanda website. We hope to bring more people to work with us on this project, and so the speed at which it happens really depends on that. But I think the next immediate goal for us is really, yes, to figure out a way to design modules for people who already have a coding background, and if they don't, to have a short module for people to just get up to speed with the amount of coding that they need, which is actually not very much. If even if you don't know how to code, there are some advanced scientific computing packages that you can use with very little coding experience. And I'll confess, that's what I do most of the time I need to do anything. I very rarely code myself. So indeed, we are planning on a module that involves, you know, more advanced stuff, and also a module that contains you know, the basics of coding for people that don't have it. So that is indeed the plan.
Thank you, Subodh.
If I could just add a very small thing on the fraud prevention lecture, along with it, I will have a live demo of like doing a fit, like fitting a mathematical curve to a data using something called a Jupyter notebook, which is an interface for learning Python very easily. And I will just leave that as course material for you, and you can, you know, make small modifications to it and start learning from it. Because the way I will be doing it will be to assume that you know no coding at all and just show qualitatively what is being done. But those of you who do know some coding can then take that as a baseline and move on to do more with it. And in later modules that we have not yet planned, we can of course use the same set of tools to teach you more and more advanced stuff. But yes, there will be a starting point if you're that interested in this lecture.
Yes, and we should also stress that if there's some students here who found that, you know, something that we've explained is it hasn't been explained well enough, or they need something explained better, please just let us know. And conversely, if there's students that, you know, would like to race ahead, we will beg your patience and ask you to wait. We will reach your level soon. but we also will, if you want to ask us more advanced questions, please do in the question and answer session. We're very happy to keep you occupied. I think we have another question coming in. No?
I think
Okay.
we can take other questions later. I think Ramesh Bhai has written that we will talk about it in 30 minutes or so.
Okay.
Yeah. We can
Okay.
move
So
on.
I will continue with the introductory lecture. So, what you're about to see, and this is something that both Ramiz and I will stress quite a bit, is that we're not interested in being, providers of facts and methods. That's not what we're interested in. We are interested in teaching you how to think, okay? And we're interested in giving you the confidence to not just take concepts that are thrown at you and just take them as a given. We are going to invite you into the subject such that this is something that you will hopefully have an internal mastery of yourself, because that is really how I think education should be always. I think both of us feel that way. And so so it really has to begin with just even seeing what it is that we're doing, what it is that we're about to do. So what is data science? It's a subject, and it is contained of two words. One is science, and one is data. Okay, so we're going to take these two concepts apart slowly and build up. So first of all, science. Maybe you've had a really nice science teacher in your schools. Maybe you haven't, but typically, people think of science as a collection of subjects. But it is not a collection of subjects. Okay, science is simply a method of inquiry. That's it. Okay, it's a lens through which we try to make sense of the world in which we're in and everything in it. Okay, and how it began. I mean, it's been around as long as humans have been around, but over the last several centuries, we've distilled a particular method. And the reason it's powerful is because it doesn't care about who you are. It doesn't care about your political affiliations. It doesn't care about where you come from. Everybody who engages in this mode of thinking will come to the same conclusions. And that is the most beautiful thing about it. I think both Ramiz and I have worked in different countries, and one of the things that continually strikes us is how many people from many different walks of lives can work together on this thing. And what science is just asking questions to begin with, and even sometimes asking questions for things that you would have not have thought to have checked. So a long time ago, people used to think that the heavier an object is, the faster it falls down. So if you're on the side of a mountain and you threw off a bus off the side of a mountain, watched it drop, a long time ago, I mean, unless you now I think we learned in class that that's not true, that all objects fall at the same speed, no matter how heavy they are. But at some point in time, we didn't know this until someone named Galileo decided to check, okay? And so this is a story, who knows if it's actually true, but there's a tower in this city called Pisa in Italy, and it's got a lean, maybe you've seen pictures of it, and he dropped, two lead balls, of different weights. And indeed, the idea people had before was that the heavier ball falls faster. It turns out that in fact they fall at the same speed. Why? Okay, so science is about making a hypothesis about what the universe should be. The hypothesis previously would have been the heavier ball falls faster. Okay, then you do a test. You drop the balls off the Leaning Tower of Pisa, and remarkably, you find that they fall at the same speed. So your hypothesis was wrong. Okay, so then you formulate a new hypothesis that no matter what weight the balls are, if you throw two balls off any height, they will always fall at the same speed. And you do the test, and it gets confirmed. Every time you check, it is what it is. So you start to form a working model of reality. Okay, but the thing is, the word I would like to emphasize is a working model of reality. Okay, the difference between science and religion is science never tells you answers. It never says it is like this or it has to be like this. the most you can say as a scientist is we have a working model of reality. Every time we check, it is like this. At any point in which it wasn't true, if we tried to test something and it turns out that it wasn't true, then maybe we need to think about a different model. So it's a repeating circle that we formulate hypotheses, we come up with a working model of reality, and we keep testing it until something says that that model isn't accurate. And this happens usually when our model fails to account for some phenomenon to some degree of confidence. Okay, so for instance, let's say we had this model that all balls, no matter what their weight, would fall at the same speed. Okay, but then if you keep doing this, you'll notice after some time, actually, balls that are bigger, independent of their weight, balls that are bigger somehow actually do fall slower. That's a bit weird. Than balls that are a bit smaller. And then you think, why could that be? And then you realize, maybe there's air resistance. Maybe the more extended the ball is, maybe the more extended the object is, the more air resistance there is, there's more, that's making it fall slower. So if you had accurate enough measuring instruments to see that, in fact, indeed, if you just really a stopwatch just to see when something fell, when you start to see that, objects that if you like more surface area or more drag start to fall slower, you realize, that first hypothesis wasn't true. It's not true that on the Earth, that all the balls fall at the same speed. Of course, it's true in the vacuum, but not really on Earth. So then you update your hypothesis. Then you say, maybe there's some air resistance, and then I have a model for air resistance, and I work that in. And then you keep going. You keep forming a model until you arrive at the next best working model of reality that you have. But it's always just a working model of reality, because if you keep going, there are all sorts of things that happen that eventually correct it, but at such a tiny level that they're not observable at the level at which we're observing balls falling with a stopwatch. So that's the process. That's what science is. Okay, it's not a set of facts. It's not a subject. It's just a method of inquiry, and that's how it works. Okay, I'm giving you a very simplified version of it, but many philosophers debate, what is science, what isn't science. But this is, to some approximation, this is what it is in its purest form. So what is data? Okay, so data is a word that is plural from the Latin word datum, which just means thing. Okay, so the way we use it in English and in most modern languages is data is just a collection or strings of information. And the information can have many, many different forms. It could be in the form of numbers. It could be in the form of text characters, words, names, anything that you might think tells you something about something that you collect. That's it. That's data. It's not that difficult to imagine. The key thing to note is that in small amounts, data is pretty easy and intuitive to understand. You don't need a science to if somebody just sort of throws 5 oranges in front of you and asks which one is the biggest orange, and that's easy. You can just look at it and just pick it out pretty fast. But then what if somebody brought a truckload of oranges and they ask, well, which one is the bigger one? Then it becomes a little bit hard, right? So in small amounts, data is very, very easy and intuitive to understand. And it's very easy to process by hand or by eye. But in large amounts, you can very, very quickly be overwhelmed by too much information. And I think the sneaky example that I think those of you who are activists may notice is sometimes if you make, let's say, an RTI request to the government, you want to know something, maybe you want to know the financial transactions of some ministry or something like this, or maybe the forestry ministry promised that they'd plant 10,000 trees in this section of of the coast, and then you want to find out if they really did, so you send in an RTI request. They're very clever. They know that the way to actually hide is by giving you too much information. So sometimes you ask for an RTI request and they give you lots and lots and lots of files in the hopes that you won't find what you're looking for, and they can get away with things. Okay, so in large amounts, data can be very, very, very overwhelming, and so we need to be smart about how we deal with large data sets, and that's what data science is. It's the study and analysis of large data sets. Okay, it is a science in the sense that it uses this methodology. Okay, it uses this lens. That's all science is. It's a lens. It's a framework in which to to try and understand something. And it uses statistical methods and modeling. We'll explore all these in great detail to understand large collections of data. However, there is an art to it, and this is very important. This is very, very crucial. Okay, if it were just an algorithm, if it were just a thing that that is just a task, a checklist, you wouldn't need humans to do it. You could just give it to a computer. Okay, so data needs to be thought about, and foremost, it needs to know. You need to first know what to ignore, if you like, or what to keep. It also depends on what questions you ask of the data. You may get different answers if you ask different questions in a different way. So, so it's both an art and a science and a method. Okay, and the goal of these lectures is to provide you the tools, but foremost, the conceptual tools, the framework of thinking in which to approach this. And this, by the way, transcends just the subject. These are critical thinking skills that you can apply to many things in your life, which we hope to incorporate in through some of our examples. So let's just run through a real life example and see how this works. Okay, so imagine I went to the taluka office and I asked for the heights and the weights of all standard 10 children in Varda taluka. Okay, and then they gave me this table. There's more entries. I just picked out this imaginary exercise. They gave me this. This is what I had in front of me. Okay, so if you can see, there's some numbers. Okay, but then there's some little things that are a bit off. Okay, so let's stop and think about all of these things. So, in general, data can be noisy. Okay, nothing is recorded perfectly. There are errors. Some things are they're just things that you won't have access to. Okay, so there will be noise. There will be garbage in your data. So you have to think about what to do with it. However, if you just think a little bit, and if you had this character unknown, then all you have to do is realize that, well, either this number is 0, 1, 2, 3, 4, etc., etc. But you have never seen a standard 10 child that is 40 centimeters tall. Okay, I mean, there are some people with health issues for which that may be the case, but it's extremely unlikely. Also, you've never seen a person in standard 10 who's 240 centimeters tall. Okay, that would be the tallest standard 10 child you've ever met. So you can fill that piece of information and say it's very likely that the number is 1. Okay, so what you've done is you've cleaned some of the data with a reasonable, what we call a prior. Okay, and that prior means simply that you have in your mind a range of the heights of a typical child, and therefore this missing digit is not 0, it's not 2 or above, it's 1. Okay, but then there are some data sets that are just very, very hard to make sense of. Okay, so if we're talking about the height of a girl in standard 10, where these two characters are missing, well, this could be, I don't know, 3, 4, 5, who knows what this could be. Okay, and also because this digit is missing, we just throw it away. Okay, this is too corrupted for us to use. Okay, so this process of when you have data and it's presented to you, it's not immediately something you can use. It needs to be cleaned. Okay, this process of applying useful priors. This prior is this notion that that we expect the values to be within a certain range, is what allows you to do this cleaning in a systematic way. Now, we're not yet done, because if you look at all of the numbers presented here, I mean, what does this mean? Okay, look, so if you're telling me that there's the height of a child to 1/10 of a millimeter, I would say I don't know about that, because how is that height? We have to think about how that data was collected. Okay, so probably what happened was some district officer came to school and had one of these weighing scales with a height thing, and are we going to attach equal significance to all of these numbers? And the answer is no, because probably the last two numbers they're meaningless, right? I mean, really things start to make sense when we're dealing with millimeters and not below. I mean, that's far too much. And so, but there's more, because although these are the raw numbers we get, we step back and we realize that actually this apparatus that was used to measure these heights and weights is really only accurate up to, let's say, 1 millimeter. And that's actually a very accurate measurement. Usually we're much worse than that. And let's say accurate up to 100 grams. And so, what we can do is we can take these numbers and immediately round them up to the nearest interval that fits within this error. And now we're ready to use the data. Okay? So that whole process is something that has to happen. And if you end up doing a career in data science, unfortunately, I hate to break this to you, but 90% of your time, maybe 80% of your time if you're lucky, is going to be spent cleaning data and making it usable. Okay, this is most of what you have to do. So this was a very simple example, but it gets much, much trickier when you get into real life. So data needs to be cleaned. And it not only does it need to be cleaned, we need to have some degree of confidence with which we can assign to the data. Okay, so if you threw me numbers like this previously, I am very skeptical about all of these. Everybody should be very skeptical about all of these numbers at the end. But when I know how they've measured, I know now I can be fairly confident that these numbers are indeed a good representation of the heights and weights of standard 10 children in Varda Taluka. Okay. So now we're ready to do some data science with it. But we also need to understand basic truth values we can assign to numbers. Okay. Mathematics is a subject that deals with pure concepts. Where do these pure concepts exist? Who knows? But in reality, when we use mathematics to model reality, like we're doing in data science, you not only get numbers, you have to have some degree of confidence with which you ascribe these numbers. Okay. So for instance, if I wanted to know what the width of a table is, for instance, I am more likely to be confident if that number was measured with a tape measure than if it was measured by somebody, standing across the room, being like, oh, it's probably, 1 meter long. Okay. Not all numbers mean the same thing. You need to know where those numbers came from. You need to know how they were arrived at. And by that, we arrive at a confidence that we can ascribe to those numbers. But there's more than that. Let's say you're just the end user of certain numbers. So you watch the weather forecast, for instance, and somebody says there's a 30% chance of rain tomorrow. What does that actually mean if you think about it? What if somebody says NCP is polling 32% in the Vidhan Sabha elections, in the next Vidhan Sabha elections? What does that number mean? Or what if somebody tells you that COVID has a 1.5 case fatality rate in India? That means of all the people that get tested positive of COVID, 1.5% of them pass. What do these numbers mean? They all need to be interpreted with care. And no number means anything in reality unless we ascribe an uncertainty to it. Okay? And this is very important. If somebody tells you something, that number means nothing unless you know how much you can trust that number. So, and this degree of uncertainty actually has different meanings depending on the different contexts in which these numbers are presented. So if somebody's telling you that on the weather forecast that there's a 30% chance of rain tomorrow, what they're telling you is that they run a computer simulation. And out of those computer simulations, 30% of them turn into rain wherever you are. Okay, that's different than you saying, that there's a 30% chance of rain. It means something slightly different. But of course, those computer simulations themselves are subject to some error. So that number isn't just 30%, it's 30% plus or minus some percent. That is the intrinsic error of the modeling of the computer model. Okay. A more familiar example, obviously, is from election polling. We know that if somebody is telling you that NCP is polling 32% in the Vidhan Sabha elections, there must be a margin of error. That means that we think that that number is accurate to plus or minus some percentage, let's say 5%. And the majority of that error actually comes from what Ramiz was discussing, which was that you don't go away and you don't ask everybody in a particular district who they're going to vote for. It's just not possible. You ask a small number of people, you ask a sample, And of course, the bigger your sample becomes, the more accurate your number becomes. It turns out actually that if you sample well enough, if you do a truly random sampling, and that's the really hard part. It's actually very hard to get truly random samples in India, because India is a very, very multi-scale, multi-heterogeneous society. We're a very different society than many other countries in the world. It's very hard to get a random sample. But if you had a really random sample, then the more people you ask, the more accurate your polling becomes. But it turns out that the number of people you need to ask is actually not that many, because of some very deep underlying mathematics that I hope to present. And so here we're coming across the concept of sample variance, meaning that depending on the sample, you're trying to understand what the true underlying reality is, only dealing with finite information. And so that's really one of the core concepts to statistics in general, and by extension to data science. And of course, there's going to be I have a lot to say about coronavirus and what all of these numbers mean. But at the very simple case, if somebody tells you that COVID has a 1.5% case fatality rate, there's really an underlying number that we don't know, which is the true infection fatality rate, because we just don't know how many people were truly infected. We can try and estimate it using random testing, and that's something that I will cover. And you'll be surprised at how uncertain we are about a lot of these numbers. So, it's been a really hard year for everybody, everywhere in the world. Where I am right now, we have a curfew. Nothing is open. None of the stores are open. And the basis for these decisions is the government modeling what's about to happen based on some numbers. And so, in some sense, we were quite lucky in India because it was a bad thing that happened, but we've actually escaped much better than other countries. But what I will do is I will show you, just how much goes into, what sort of thinking goes into this, and it's a lot, and there's lots of numbers that by the end of my first formal lecture, I hope you will feel empowered that if you see a certain number, you will maybe the advertising is that you will get to apply Bayes' theorem, which is your way of inferring what happened given a hypothesis. Okay, so it's a very, very novel way of thinking about probability, but once you see it, it is actually completely obvious. Okay, so I hope to really, really drive that point home in the next formal lecture. But the essential point is that numbers mean nothing unless you can assign a degree of confidence or uncertainty to them. And what the knowledge of statistics does is it empowers you to be able to interpret numbers. Okay, just like in education, in the humanities allows you to interpret ideas. It encourages critical thinking. Statistical and scientific literacy will allow you to engage in critical thinking with respect to many other things that are relevant to your lives. And this is something I hope we will really make as a foundation in the coming course. So I'm going to hand over to Ramiz soon. But that's our aim, is over the next lectures to give you an overview of the basic concepts and applications, and it's an invitation to a deeper study of the subject. So really view these introductory lectures as an invitation for which we aim to provide the mathematical and computational tools on the digital Nalanda platform. So I'm going to hand over to Ramiz now, because he's going to take over to his introductory lecture. So I'm going to stop sharing, Ramiz.
Can you see my screen now?
Yes.
Okay. Let us. Right. So Subodh asked me to give a lecture. Well, Subodh designed the plan for this course, and he said on the second lecture you should say what do you need to become a data scientist. And to be honest, I'm not a data scientist. I'm a high energy physicist. But I have found that almost any conversation people are having about data science, I'm able to follow and also in some ways contribute positively to it. And consequently, I volunteered. So this is my idea of what you need to become a data scientist. It is not necessarily the average opinion of every person in the world who describes himself as a data scientist. And like Subodh said, data science is a very emergent, it's an emerging field. It's a field. There are people of various different types who consider themselves data scientists, and they all have different skill sets. And so one of the things I really want to emphasize is that we all of them need to talk to each other. Even the ones who have advanced degrees in data science, they are not necessarily ideal data scientists. They should all talk to each other. But if I had to narrow down one skill that I think, or one body of knowledge that I would think is extremely important to be a data scientist, is something called statistics. It is often, people are not really sure what statistics is. For example, if you tell somebody what physics is, if you ask someone what physics is, they'll tell you that physics is the study of energy, or of physical systems, or of natural phenomena at a fundamental level, etc. If you ask people what mathematics is, they'll tell you it's logic and constructed applications of logic to understand numbers, and how we use it is the language of physics, etc. And in that way, what is statistics is a really open-ended question. People have debated it for a long time, and they have concluded that statistics is not a field of mathematics, or at least a majority of statisticians believe it is not a subfield of mathematics. They believe it to be an empirical science, in the sense of what is good statistics it is something we have to learn from practice. It is not something to do with the internal consistency of a model. But nevertheless, if I had to explain to you what statistics is from very, very basic ideas, I would say a statistical question is a question that does not have a single answer. It is a question that for which there are many answers, and we are interested in then what I would call the distribution and the tendency of the answers. The two words key here that I have expressed in blue are distribution and tendency, and we'll get to understand what that means with this one example. I can ask, how tall are you? And that is not to any of you people, any of the students who are connected to this, and you will give me a number, and that number will, unless if you're a growing child, of course, if you're above, let's say, 25 years or so, that number will remain more or less constant for the foreseeable future. So it is not really a statistical question. It does not really vary. That you should not believe that statement completely. There is some nuance to it. You should think about how we measure the heights of people, and that you understand that the tools we use to measure heights are not ideal. So there are the question, how tall are you, can be statistical if you start thinking of uncertainties and error bars and margins of errors, like Subodh was mentioning in the previous topic. But for this one example, where I assign to each person a number corresponding to his height, and let us believe that number is a real number, a very, very precise number, then it is not a statistical question. But I can ask a question, how tall are Indians? And that, because there are 1.3 billion Indians, then you have the number that corresponds to the height of each Indian, and that is a statistical question. Then you have a distribution of those heights, and you have a tendency for those heights, and that gives you what you would say I think the average Indian is 175 centimeters tall. We know that doesn't really represent any individual Indian. For example, I am 172 centimeters tall, whereas Subodh is, I believe, well over 180, maybe 185. He's a very tall Indian. So you have a collection of numbers that correspond to the heights of different people, and then you will have what you call the average. So if you ask somebody, how tall are Indians, and they're supposed to give you one number, then that is usually the average of a distribution they're talking about. Or there are other quantities that we will slowly learn on the job over the next over the next lectures, and these are what are called the measures of central tendency. So the mean is what you think of as really as an average. The mode is what you think of as the height that occurs most often, and we will introduce this in detail later. But there is an underlying concept of what a probability distribution, or even if you don't have a concept of a probability, what just a distribution is. And that is at the core of what statistics as a field is. You can ask a question, how many Indians are 175 centimeters tall? And you will actually, if you know, the moment I ask you that question, you'll give me an answer, and then I will argue against you, and then we will quickly realize that that is not really a well-defined question, because like I mentioned, every measurement has an error associated to it. So if you believe 10 people in a group of, let's say, 100 or 175 centimeters tall, but then you decide to measure their heights very precisely, you will find that some of them are 174.6 centimeters tall, so they're not 175 centimeters tall. Some of them are 175.5 centimeters tall, so they're not exactly 175 centimeters tall either. And if you try to get to a very precise answer to this question, how many Indians are 175 centimeters tall, the only way you can conclude is that the more correct way to ask that question would be something like, how many Indians are between 174.5 and 175.5 centimeters tall. So to understand this better, what we use in statistics is a figure called a histogram. We will actually study this figure, what this exactly means, with more examples in the upcoming lectures. But if I ask the question, how many Indians are between 59.5 centimeters tall and 60.5 centimeters tall? So that definitely cannot be 400 because there are too many Indians. But let's say, how many of the total students enrolled for Nalanda Academy, the digital Nalanda Academy, are of that height? And then, this is in inches, not in centimeters. Forgive me for that error. But if you make that question and you make a count, and then you draw a diagram like this, that is called a histogram. And understanding what a histogram is really, let's say, it is one of the single most important and key aspects of statistics. So what you think of as the mean is really the middle of this distribution, of the shape that you see here. What you think of as the mode is the one where you see the maximum number. So in the case of this red distribution, which corresponds to female height, it is the one that corresponds to this one, which has the maximum number of women in it. And for the male height distribution, it is this one, the mode. And then what you think of as the median is really the middle value of these things. So in this distribution, you will see that the mean and the median and the mode all are roughly the same, but in general, they need not be. So at the core of the idea of a histogram is, of course, a diagram like this called a histogram. There is something called an interval, which really corresponds to the width of each of these bars that you see here. And then there is something called a bin, which is really what each of those bars represent. And this is a core concept of the tool called, this is a key and core concept at the center of what we believe, what you think statistics is. And these are concepts that you will learn on the job while we go through the next slides. But you see this shape here. This shape can actually be drawn in a very smooth way, and using a mathematical equation. And when that shape is drawn, what we call it is, mathematicians call it a normal distribution. Some statisticians call it a Gaussian distribution. They're all the same thing. And this is the single most important, let's say, shape in statistics. You will see this in everything. If you plot the distribution of heights of people, you will see this shape, and this is called the normal distribution. We will truly learn to understand what this distribution really means. And a simple example that you can look up to understand, to get a very intuitive understanding of how that shape arises in nature, is something called Galton's board. So here is an assignment for each of you. Go to YouTube, type out Galton's board, and watch the videos, because you have a bunch of balls here. They always fall on these pins. At each pin they fall, they have a half probability of changing direction to either side. And of course, to reach the extreme sides, they must have always gone to the left. and to reach the extreme right side, they must have always gone to the right. And all those probabilities, the ways in which you can think of reality dividing itself, adds up in such a way that finally, if you throw many balls, you get this distribution, the same shape I showed you earlier. And that really is the normal distribution, the Gaussian, and it is a function that you cannot avoid in statistics. But Subodh is going to be teaching you about statistics using purely 10 standard mathematics, or up to that is what is called discrete statistics, where instead of asking questions like the height of a person, where, like I said, you really need to think of error bars assigned to each value, he will start with examples such as tossing a coin. So if you toss a coin, you always get only either head or tail. You do not really get anything in between. Whereas if you measure people's heights, you do not get exactly 174 centimeters or 175 centimeters. It will always be a number in between. And that is the key difference between these two things, that some of you who have learned statistics learned calculus really understand what I'm talking about. Some of you probably don't. So we will try to introduce that idea in many different ways. But we'll also, on the job, to become a data scientist, you have to understand these concepts of probability distributions, both discrete and continuous. But you have to also learn Bayes' theorem, which was mentioned on Subodh's slides, and he mentioned that if you understand that a COVID test has some probability of being false negative, then if you take it and you find that, false positive, and then you take it and you find that you have tested positive, there is still a small chance that you do not have COVID. But that really depends on what kind of test it was, etc. And it all really is a very nice intuitive thing called Bayes' theorem, which will be taught to you. Then the concepts that I mentioned earlier, such as point and interval estimates. A mean is really a point. How do you assign a number to a question when the answer is really a distribution? And that is the question of how to make point estimates. And interval estimates would be to say, okay, the most number of people or some number of people lie between these values of heights. How to make such statements. These are the things that really form the core of what statistics is. There is also a concept of a p-value, which is something that can be very intuitively taught. If someone had to make a bet with you on some based on some experiment, and it is at the core of it a simple probability defined in such a way that you make statements about some hypothesis, and these are the concepts that you learn. These are the concepts that form the core of what I would say is statistics. But we are going through an era where data is defining itself, and statistics is an empirical science. So maybe in 10 years, if someone was to tell you what do you need to be a data scientist and statistics is it, he might have a completely different take on it. I cannot really be sure. So these are just my ideas of some key concepts that form the idea of statistics. But to be a data scientist who's also doing his job, you need tools to process data. For example, if you try to download, let's just say, the information about all the COVID patients in Maharashtra, which is really available as Excel files and data files and text files on many portals that I can send you links to later, you'll see that they're extremely large numbers, collections of numbers, names, etc. And obviously, no one can make sense of it. And to start working with it, you need to know actually some programming. So it could be as simple as C++. It could be something as, C++ is actually not the simplest thing here. The simplest thing would be R or Python, but C++ is in many ways let us say, the most the fundamental. For example, much of Python is written in C++. There are different difficulty levels. So in the lecture that I will be handling on fraud prevention, I will be using what is called a Jupyter notebook, which is a very easy to use interface. In fact, I hope to be able to use something called Collaboratory to get each of you started on a place where you can run Python code on Jupyter and run very basic ideas. But I will be straight away giving you an out-of-the-box working example of a worked out thing. And then, then you can make modifications on it. So I will not be teaching you a programming language in this first module, but in the later modules, maybe we can actually do that, or I can point you to resources where you can teach yourself this. But programming languages are just one way. For example, this is a figure that is made in Python, and this is just one way to visualize data. There is a tool called Microsoft Excel that a vast majority of you probably have access to, but it is paid software. So if you don't want to use that, there is open source alternatives like OpenOffice, which has very similar software. And in fact, in the language of theoretical computer science, if some of you are aware, the tools such as Excel and OpenOffice Excel are Turing complete, which means if you have some imagination, anything that can be done with a programming language can technically be done also in Microsoft Excel. So I will not actually be teaching you anything about Microsoft Excel, but it is very simple to make, to visualize data using Excel. In fact, to do quite a bit of data science in very highly paid jobs, all you need is Microsoft Excel. So do not be intimidated by the need for programming. Programming itself is not that hard. It may be a little hard, but it is definitely not. Microsoft Excel is extremely easy, as well as all the alternative tools that for spreadsheets that you can use. And that is technically all you need to do to data science. And the main purpose of all of these tools, of course, and Excel is, and of course, of all the tools I mentioned, is to really visualize large data sets. Because like I said, if I give you 10,000 numbers, you have it is very difficult for you to give me any meaningful information from it. So you have to turn it into a histogram. You have to fit a shape to it, to the shape of the Gaussian or the normal distribution that I mentioned earlier. And then from that shape, you can give me some meaningful information. And that is really what the purpose of a tool to process data is. But one of the things that I want to emphasize, because Subodh mentioned that we really want to teach you how to think critically, is that to be a data scientist on a specific data set that you're working on, you need to really understand at the end of the day how the data were gathered. And what I mean by that is something very simple, but it is also at the core of almost all of data science that is quite often ignored, is that if you have seen surveys like this maybe on different websites, maybe on questionnaires. Such a survey is called a Likert scale. It will give you it will make a statement, and it will help you either strongly agree or strongly disagree. And this is how a lot of people gather data on different things using methods such as this. But we already know that such a method is quite often extremely biased, in the sense, if the scale is made in such a way that there is already a tick mark there, and you use your mouse to move the tick marks around according to your response, then quite often you find that a larger fraction of the responses tend to what the default value is, because people are just lazy. So you need to learn to clean data based on how it was gathered. Another bias that is often seen in using questionnaires such as this is that a lot of people will just either respond strongly agree or strongly disagree. The middle points do not apply to them. So even though their actual response might be something closer to this, because of just ease of marking or clicking, they will, or just, some people think in binaries. It requires quite a bit of work to train people to think in nuance. And so this extreme responding is a standard bias with interfaces like this. There are also other interfaces other issues that people have found in surveys like this, which is that the answers quite often vary depending upon how you order the questions, etc. So unless and until you really have an understanding of all of these biases, you will not make, or your conclusions about the output from such a process can be wrong. And what this means, unfortunately, is that if you're going to analyze COVID data, at the end of the day, you need to understand a little bit of medical science and a little bit of epidemiology. So in some sense, I was deeply impressed with Subodh's approach of teaching you what data science is by starting with what is science, because as you get into a data set and analyze and understand it, you will learn that you have to approach all aspects, including the empirical aspects of how that data was measured, how it was gathered, etc., in a scientific way. And so yes, I think we are on the correct track of trying to teach you things from fundamentals. So really, these are the three things that I think are most important when someone asks you what do you need to become a data scientist. But like I said, I am not a data scientist. This is just my opinion, and this might not be what other data scientists will tell you. You need statistics, you need the tools to interpret data, and statistics is really a mathematical field. The tools to interpret data are programming or software packages, and then really an understanding of how the field in which the data was gathered works. But once you have learned those things, there are a large number of career and professional possibilities that data science opens up for you. For data science, a data-driven approach can, for example, improve your performance in your current job. For example, one of the questions I saw in the chat from Sandeep was that he works for a power station, I believe a thermal power station. So maybe it burns coal to generate electricity. And his question was, how can data science help him? And there are many ways, and I believe much of these are already being implemented because our power systems are quite efficient. For example, you can monitor how much power is consumed by people during different parts of the day, and you will notice that every day it goes up between, let's say, 5 p.m. when it starts to slowly approach darkness till about 10 p.m. when people stop switching off lights. And then by monitoring this data over different times, you then learn when you want to increase your output. You can monitor the prices of coal against different phenomena that affect the market, and then you can come up with a way where you can buy your stocks of coal for your thermal power plant, depending upon by predicting or by understanding the periods at which its value will be the lowest. And you might be, for example, a milkman, and who's trying to differentiate himself by providing, let's say, a very specific type of milk from a specific type of cows. On your first 100 days of job, you can monitor how many orders you get on different days, and then that will tell you in different days of the week what roughly your demand is going to be. You can use that to forecast it, but you also don't want this to be a source of major risk for you. You do not want, because milk is a perishable commodity which might not last more than 3 or 4 days. You do not want to build up stocks that maybe on a day of a festival or during a specific month of the year the demand goes much lower. So by understanding the process of how you have gathered data so far, the mathematical modeling that you're putting in to make these forecasts, you can minimize the risk, you can maximize your profit. You can even decide that by accepting some more risk, you can make you can increase your chances of profit, etc. And these are all things that will help you improve your performance in your current job, but it will also open up new career avenues. And if you just type out data science jobs into Google, you'll see that on nowcree.com, for example, various companies are looking for people who are interested in analytics. In companies who are involved in the logistics spaces, especially, are involved in are explicitly looking for people who have degrees in data science. Marketing, for example, if you're on Facebook or on a specific website, you will see ads on the side of the pages, and you will see that these advertisements are targeted towards your behavior based on what you have been looking for earlier, what you have searched for, and how to optimally target advertisements so that the probability that you will click on it is maximum, etc. Are things are things that are at the core of or are things that that data science will enable you to do easily. This does not mean that I do not that I think these are good applications of data science. In fact, it has been said that in this century, we are some of our best minds are spending their time trying to figure out how to sell more ads, and that may be a systemic problem we have to recognize. But these are career avenues that will be open to you once you are very competent in data science. Unfortunately, much of the majority of the companies here will probably want you to get a formal certification. Maybe you having taken a course here might not be sufficient, but I'm sure we can. There are ways to help you out with things like that. So a data-driven approach can improve your performance in your current job, because every interaction you have as part of your job is giving you a data point, and it is a question of how well you think as a person to gather information from it and help your performance in your current job. But it will also open up new career opportunities, and but that really is one of the features we have seen in the last 10 to 20 years is that this has really blown up. It has taken off a lot. So in conclusion, in these preliminary set of slides, I think I have given you my opinion of what you need to be a data scientist and my opinion of how it will help you. I hope that this has been sufficient for you to stay engaged with this lecture series in the future. We will really be going with it as a story, and in the process of the story, you will pick up key concepts, and you will, as Subodh emphasized, learn to think of them critically. So we will show you things, and we will show you how most of what we are saying can be wrong, and so you need to refine the thinking further. So that is all I have to say for this slide, and maybe I will I will stop now, and either we can take questions, or maybe Subodh has something further he would like to add.
Well, I mean, no, nothing more than yes. So this does conclude the formal introductory lecture that we wanted to give. So I hope you've got a sense for where we're planning on taking you over the next several lectures. And as we emphasized before, this is really just meant to be an invitation, right? So this is just a way for you to see what's ahead. And of course, the real nuts and bolts of data science is more advanced stuff that requires tools to process data itself. And so we will be designing more modules going forwards, hopefully in the next coming weeks or months. So if you have any questions, we're here to answer your questions. I should also stress that every Friday, I think, what is it, 7 p.m. we planned it, or 6 to 7 p.m. we have a question and answer session that either both Ramiz and I or one of us will be present for. And all of our lectures, all of our formal lectures anyway, will be conducted in English, but they will be recorded versions in Marathi and Hindi as well afterwards for you to watch in your own time. And also, I will endeavor to put up exercises and other material and links to material. Everything should be freely available on the web. And so, yeah, so if you have any questions, please just ask us.
Yes, some questions are being put on YouTube also. So Ashmita is asking, would we have the opportunity to work on live projects? Like how data science is applied in industry, she's asking.
So in industry-specific applications is something that I suppose Ramiz, we're both academics, so we're a bit far removed from. But for instance, our aim, and again, like we mentioned, these are just introductory lectures. So, but there's still going to be lectures at a level that you will be taken to a somewhat advanced level. We hope that we would embolden you, at least maybe give you the tools to go and look for yourselves. And then if you want to go and apply something yourself, you can come and talk to us and we can help you think through it too, even if it's not familiar to us. Of course, the real artillery, the real sort of machinery that we want to provide is going to require a bit more of a formal introduction, to using code, Python or Excel or various packages, and those we hope to prepare fairly soon. But indeed, ultimately, the goal is to provide what you asked. We do want to interface with real life examples, and in particular, if you have an example from your field or something that you're working on that interests you in particular, then bring it to us. Then maybe we can use it as a module or an example which to teach with. It's much better to teach that way, I think. Ramiz, I don't know if you have anything to add.
Yes, in the fraud prevention, that lecture, I will give you just one working example of how it is used. I am downloading the data from this web page called ourworldindata.com, and it has some examples. I'm not sure of how real that data is. For example, companies that are actually using the data probably not making it, but we can understand qualitative aspects of how those things work. And that is a real industrial, real life application. And then you will have a notebook in which you can just click run and see what happens. And then depending upon your proficiency level of the underlying concepts, change things and play with it. And it'll be very simple, don't worry. That is one where it will happen. But what Subodh said is right. I am an academic, he's an academic. So when we are asked to think of these things, we don't immediately think of how is it useful in the short term. We think in terms of what does it look like? What is the shape of this thing? So yeah, if there are specific industrial applications that you would like to know about, you're welcome to email me. I'll type out my email address into the chat, and I will put you in touch with somebody who knows something about it. So I went to the college I went to has lots of people in the industry, and there is an alumni network, and I would love to put such networks to use for everybody. So yeah, I will type out my email into the chat.
So it's an introductory session for us, and also students need to know this, that first of all, we need to know what is data science, what is statistics, and this kind of approach. See, industry, whenever you go to industry or all, this kind of basic knowledge is very important. So we are trying to make a basis first, then you will be free to take your own way into any specific industry. There are multiple applications of data science. So any field that interests you, you are free to approach that way, or you can directly pursue that way. But these basics are very important, which we are trying to build in our school. Another question is, I'll put it in generic sense, that people are asking that about background, that is there certain background necessary? Like server also is telling us only till 10th class mathematics is needed, but somebody is asking many of people are engineers or from sciences background. Somebody is from economics background. So the question about background is very much asked about, sir. So anyone of you could clear on that?
Yeah, so I suppose the challenge for us on our end is how to design a course that will be interesting to people of a broad range of backgrounds. So we would like to emphasize that this begins with an introductory set of lectures, and these are only meant to fix concepts and to show you the path ahead. What we intend to do is to provide more advanced material in 3 different streams. One, which will be very basic, and it assumes only 10th standard mathematics and no coding. The second one will only assume 10th standard mathematics, but we'll build up coding. We'll assume coding, or if you don't know coding, we will have a separate module to teach you that. And whatever mathematics we need, we will teach along the way. Okay. And then the final one will be quite advanced, which assumes that you already know some advanced mathematics, know how to code, and then we can progress that way accordingly. And the goal is that if you know absolutely nothing to begin with, you can work your way through these modules yourself. So it should be completely self-contained. Now, I understand that for some people, you will have already an engineering background and you will feel, maybe you already know this stuff. So in that case, I would suggest that you just tell us and then you ask us for more advanced material, because in some sense, you are not necessarily our target audience. Our target audience is, really to get people from a very basic level up. But that is not to discourage you from attending our lectures, because we hope that we will still provide you things that you will not know before. Certainly what we hope is to provide you a different pedagogical path through the material that will be hopefully very different from what you learn in your classes or in your university. And with any subject, it's true of any subject that I've come across, you can never see anything enough. There's always different ways of thinking about things and doing things that, if you're really interested in mastering a subject, you will always benefit from. But indeed, these introductory lectures are supposed to be very, very basic by their nature. We hope to provide the more advanced material very soon on the Digital Nalanda portal. But at any point, our goal is not to restrict you. If you're attending the lectures and you want more advanced material, please just tell us. We're very happy to provide it.
Great, sir. Any more questions from the students, both on YouTube and who are attending live lecture now? You are free to ask. Or anyone who wishes to ask directly, they can raise. So Nilesh is asking, how much SPS is relevant to process large data than other mentioned like Python? I mean, IBM SPSS he's asking, is it how much relevant to processing large data?
Ramesh, do you want to take this?
Yeah, because I have actually never used SPSS. I have friends in the industry who do. It is not an open source software, like you need to pay for the license, I believe. So if it is very important for you to learn SPSS, maybe I can put you in touch with somebody who wants it. But this course will not be touching SPSS at all, as far as I can tell. The things you will do in SPSS, you can do using Python or even Excel, if you know exactly what you're doing. It's just that SPSS has a lot of built-in modular functionality, and then they have a training program. It's a business, so there will be, as far as I can tell, there will be no connection between anything we teach and specific things of SPSS.
Yes. Any more questions? Like many of the things will be like when we start the course and when we start the real-time like assignments, people will be having queries and all. But still, apart from that, any questions regarding the course and its structure, students are free to ask now. If like, because sir has been mentioning it that language is not a barrier. The live lectures will be in English, and also recorded sessions will be there in Marathi, Hindi, and Malayalam. So, okay, one question from YouTube. I didn't know coding, but still want to pursue data sciences as career. Should I start right now? Or asking, so what would be a good way to do that? I mean, he's asking about non-coding background, a person who is from non-coding background. Should they start now? I mean, yeah, yes, sir, please. You can.
I mean, yes, I would say, look, coding is something that you can easily be intimidated by if you've never seen before. If you can think logically, you can code. It's just a language, okay? So asking, should I start learning? It's like, to me, the same question is, one day I'm going to move to, I don't know, Gujarat. Should I learn Gujarati? It's like, well, of course, the earlier you start, the better. But once you get there, you learn fast enough. It's not going to be so having said that, it's a language, but of course, the more you practice a language, the better you get at it. Okay, so of course, if you want to, if you really want to pursue a career in data science, you're going to have to learn how to code to some level. Although Ramiz has mentioned that there are some jobs where even being able to manipulate data in Excel is sufficient. The sort of the path we have in mind is for somebody who really wants to embark on the path of, let's say, a data scientist. So let's say they want to put on their CV, I am looking for a job in data science, where a range of companies might look for a range of different skill sets, and so you want to be as versatile as possible. So for that, knowledge of coding is quite important. And so to stress again, we're not assuming that in the beginning lectures. The first 4 or 5 lectures that we present doesn't assume that. It's a separate module, and then we'll create more modules where either it's assumed or we teach it as we go along, okay, with examples, and maybe we'll even have like little workshops where people can learn how to code and things like this. And so in general, coding is something that you can learn by yourself at home. There are many excellent books that we can point you towards that I hope are freely available. And it just takes some practice, and you start slow and you work your way up, and then before you know it, you're writing Python scripts to clean data and analyze them. It's just about practice. That's all it is.
Great. Any other questions? You may also raise your hands and I'll unmute you all if you want to ask it directly. Do this Adarsh Ranjan is asking, does this course make us industry ready?
Yeah, unfortunately, this course will. So the problem is, the way the society and life in general works is, we have to have educational qualifications. We have to have pieces of paper that say we can do things in order for people to give us jobs to do these things. This is the unfortunate aspect of how society works. Now, it doesn't necessarily mean just because you have a piece of paper with a degree from a fancy university that you know what you're doing. Okay, and it also doesn't mean if you don't have a piece of paper, you don't know what you're doing. That means there are very often people that know, they're very skillful at various things, they don't have a degree to show for it. Now, if your question is, will this course make you industry ready? The short answer is, once you work through all the different modules that we present, that we hope to present, in the near term, say in the coming 6 months, 6 months to a year, once we have all of those, once you get to that end, I personally would consider you to be equal. I could drop you in a helicopter in the middle of a problem somewhere, and then you'd be able to figure it out. Okay, so from my view, indeed, you will be industry ready. Now, in practice, what does that mean? No one's going to give you a job, taking courses online with us. But what it will do is it will very, very, very well prepare you for a formal qualification, to the point where maybe you'll fly through it, and then you'll get very good grades, and then maybe you'll be recruited by a very good company. Afterwards, you'll be topping the class, right? I mean, that's our goal is to get you to that point. So indeed, so your answer to answer your question in 2 different ways. Our hope is to provide you with the understanding that makes you industry ready. But of course, to get a job in industry, you're going to need some formal qualifications, which we hope will be easier for you to obtain, knowing the material in this course.
More so, because going into this domain is also necessary, and even before going into industry, everybody is asking about experience. So at least first delve into it, and then you could choose in which industry you have to focus. So consider this as a chance to first get yourself introduced and yourself get averse with this kind of technology. Another question is from Sandeep. Are we going to learn machine learning as well in our sessions?
So machine learning will be a whole other course. Okay, so they will not be under introduction to data science. Machine learning is a whole other course. So that's going to also be, it's going to be a part of the same school, but it will be another course. The advantage is if you master the material in this course, you will find learning machine learning not so difficult. But it's indeed it's something that we plan on doing in the future. We gave a name for the school that we're trying to curate for Digital Nalanda, and that is one of our goals. Yeah, so the short answer is you're not going to be learning machine learning within the course on Introduction to Data Science, but it will be something that we are planning on adding. So if anybody has any other questions?
If yes, okay. Any other questions? Okay. One question is Sharad is asking on YouTube: is knowledge of C language useful to become data scientist? Basic programming he knows. So he's asking, is it useful?
I'll let Ramiz answer that one.
Knowledge of C is useful, and it is very good to become anything. It is, it is. If you really understand C or C++ very well, I think you would understand many aspects of logic and computation and how a computer works, etc. And it's a strong thing. Within data science, yes, it will help you because C++ is a compiled language. It is very fast. If you try to do the same thing in Python and C++, you learn that writing things up in Python takes much less time than in C++, but eventually when you have an extremely large data set to process, because Python is high level, whereas C++ is a somewhat lower level language, it will do things much faster. You can, of course, optimize Python to do things almost as fast as in C++ or C, but it never really gets there. But I have to emphasize, this course is not going to assume anything about your knowledge of C in particular, and later modules also, if we are going to teach you programming from scratch, it is going to be with Python, something that is C++ is extremely useful. In fact, you do need it to solve and C, of course, C and C++. I use that interchangeably, even though I know they're very different things, but with some commonalities. So that is the level to which I am conversant with C. So yes, if you know C very well, it will be very good for you. But it has close to nothing to do with this course or even upcoming modules, because I don't think teaching with C as your basic programming language is very easy. It will be quite a lot of work for me. Sorry.
Another very much, even I am curious about that, because this is a very much new thing, data science, but you both being into research, and you both being into physics and very much into sciences. So how did you land up into this? Is it very much needed in, even the people were asking about industry only, but even in academics, even in research, the application is very much adapted. So can you both, any one of you could tell about this kind of application, which made you fall into this also, going to this data science stream also?
So I have a confession to make, which is I don't really deal with. I'm a theoretical physicist, right? So primarily I don't deal with data. But of course, in order for me to understand what people are telling me from the results of experiments, I need to understand what they're doing. So this is how I got to know the subject. Now, let me answer your question in a slightly reversed order. So very often people end up doing degrees in science, and they do research, pure research. Let's say astronomy. Just looking at galaxies and all this thing. And then afterwards, they don't have a job, right? Because to do pure research is very difficult. So what field do they go into? They go into data science. Data science is one of the biggest employers of people who come from a science stream. Okay, for the simple reason that scientists are particularly trained about how to ask questions in a particular way, and so if you watch Netflix or one of these, and they have recommendations. These recommendations were designed actually by people who have training in science. Now to flip it back around, right? So if if you have a strong background in data science, the number of fields in which you have access to is immense. Okay, so I will tell you. Let's just say you want to work in science, but let's say you don't necessarily want to go through the whole thing about doing a PhD in something. You know, there are telescopes, there are radios. There's radio antenna looking at things in the universe out there, where the data coming is so much that they need to have a team of professional data scientists basically help them manage their data. Okay, so there's the scope of application is, if you have these tools plus the willingness to learn a few basics of another field, the job opportunities are immense. They're really, they're quite vast. I'm going to let Ramiz answer the question as well, because he will have his own unique perspective on it. But that's my answer, is that in most scientific experiments that deal with large data sets, we have to think like data scientists to understand what we're doing.
Yeah, so Subodh's a theorist, and his job is to, write down maths that will describe the universe, and to tell him what maths is more likely to be correct. Experimentalists and observers then have to extract something from a large amount of data. So that's how it comes for him. In my case, I have always actually worked with data. I am an experimental physicist, or sometimes maybe I say phenomenologist. You can look that word up. It doesn't really, it's a thing that exists only within particle physics. So, for example, I did my PhD in something called the Ice Cube Neutrino Observatory. You can again Google this. It's a big block of ice in the South Pole. So this is naturally occurring ice, and it's like 1.5 kilometers deep, and we have drilled holes in it, and we have put something called photomultiplier tubes. And then what happens is particles come, they interact, they emit light within the ice. And so they show, you read that out onto a computer, you end up with a large amount of data. Every day you have something like 3 terabytes of data, at least. And that is not even at the level at which, the detector sees it, because you cannot save all the data. You have to already apply some criteria we don't have good enough hardware to handle all the data that the detector could, in theory, gather. So you use some logical criteria to reduce that data. And at some level, we have every day 3 terabytes of data. And if you were to check the Wire Science 5 days ago, it spoke about us discovering an event called, it is a thing that happened in physics called the Glashow resonance, and that involved finding a single event among this data from 4.5 years. And in each second, we see about 4,500 events. So you can calculate this roughly, how big a problem that is. In each second, we see 4,500 events. And we found one event that looks like a specific physics phenomenon we have been looking for in about 4.5 years of data. So yeah, just do the multiplication and see how small how big the denominator is with respect to, and that involves all aspects of data science. It involves almost everything I spoke about today, but much more advanced concepts. And I have to be honest. So yeah, I do not call myself a data scientist, but the reason I believe I could be convinced or considered somewhat competent enough to teach a course on data science is because I believe I use all the tools in every day as part of my job. So yeah, that is the answer I have to give you. Sorry.
This is great, sir. Great to have you, both of you, and much of the application-based approach is there, and it is also very much useful. Even this kind of pedagogy is also useful because it teaches students to how to approach also things, because much of the theory and practical thing is also boring. An application-based, application-centric teaching is always much more, people could connect, or students can connect properly. We have come to the end of the session now, and also faculty they have taken out time for us. I guess we don't have any more questions. One question is about when are the classes starting, and only this question. And so you have to visit our page, School of Information and information and data science page of Digital Nalanda for every update of this course. And also there is a link for joining the live classes over there. So students, everyone is requested to please go and over the check out the page first, know more about the course and also about the faculty. I guess we are like very short of time, and Ramesh sir and Subodh sir have other engagements also. They have taken out their valuable time for us. I from Digital Nalanda, like I offer my thanks to you both, Subodh sir and Ramesh sir, for conducting this introductory session, and also we look forward to much of interaction again, and also thank you again for joining us and making this school possible. Thank you so much, sir.
Thank you very much, Subodh, and thank you everyone for attending today. And on Friday, we'll be back online for a question and answer session at 6 p.m. So if you didn't get a question in today, feel free to ask us then. It'll be much more informal. And the lectures begin next Monday, same time. Bye, everyone.
Okay, bye. Thank you so much, sir. Thank you, Ramesh sir. Thank you, sir. Jai Bhim.